discussed several methods for fabricating the composite materials, and now we study a little bit concerning how to machine the composite and what we should to remember during this machining process. Yes, and machining process used to fabricate the near net shape component, of course. So, for example, in the case that we need to drill the hole for using fastener to join different plates together. If it's large enough and you cannot apply the adhesive in order to stack them together, but instead you need to use some kind of rivet, and then you need to drill the holes. And basically, it is involved in the trimming process in order to remove the excess material from edges or from drilling holes to assemble different plates together by using fastener. Trimming, you can use the high-speed saw and router uh, just to align the position uh, of the drilling tool. And this process is a little bit tricky for the machining composite materials because we need to avoid the delamination damage. Like on the right side, if you apply the pressure which is higher than enough, and then the tip of the tool, we intend to create the damage regarding the material delaminations. So there's the separation between different layers. And this is preferable to use the word Z cutting for trimming the carbon epoxy composite in order to in order to have the high accuracy and with little edge damage. And we can also use the high pressure units using the alumina particles as abrasive. Yes, for the machining, for trimming actually process, and this is preferable use in the aerospace industry. Regarding the hole drilling process, to example with fastener, we use the specialist drill bits. So we use the flat to flute dagger or for flute dagger on top of this line on the right side to drill for the how can I say carbon fiber reinforced epoxy composite. But again, you need to apply an appropriate cutting force and the feed rate. Yes, if you use the low cutting force, but you increase the feed rate, which means that you insert yes with the distance higher than enough, and then you also create the damage regarding the material delamination. Issue, yes, you have issue concerning the lux force parameters, the force parameters, and the feed rate parameters. So if you use the force larger than enough, and then you push down, you push down, yeah, too much the, uh, the cutting tool on the drilling tool, and it leads to the formation of the delamination cracking ahead of the drill bits. On the other side, if you apply the high feed rate, and then this machining process will create the high friction temperatures, and this will overheat polymer matrix, and therefore, yes, polymer can withstand high temperatures. And if you heat the polymer, yeah, problem will occur, of course. And you have already studied the thermal degradation of the polymer, and please keep in mind that within the chapter 4. And the heat will also affect the dimensional accuracy, the strength, and the materials. In particularly the matrix materials, which is made of polymer. And if we consider the aramid or the Kevlar fiber composite, and this composite is quite difficult to drill and tendency to create a fuse and phrase. Dạng như cái tơ rối ấy. Bởi vì khi mà khoan vào thì nó sẽ bị nát cái lớp reinforcement ra, và những cái sợi reinforcement nó đứt ra thì nó sẽ nó sơ ra, chứ không phải là chúng ta cắt được một cái lỗ nó rất là trơn, rất là ngọt trong đó. Đấy là một trong những cái vấn đề liên quan tới khoan cái vật liệu composite mà được gia cường bởi sợi Kevlar hay là gọi là aramid fiber. Thì trong nhiều trường hợp thì chúng ta có thể sử dụng chất dính kết nó cũng bằng polymer luôn để chúng ta nối hai cái tấm composite lại với nhau. Tuy nhiên không phải trường hợp nào thì chúng ta cũng sử dụng cái chất dính kết để nối chúng lại với nhau được. Và trong những cái trường hợp đó thì việc nối các cái tấm khác nhau thì người ta vẫn sử dụng các cái phương pháp khoan tạo lỗ, và sau đó thì chúng ta bắt có thể là bù lông, có thể bắt đinh tán, đúng không ạ? Và trong những cái trường hợp đó thì cái khoan tạo lỗ là cái mà chúng ta phải xét liên quan đến việc là gia công cái vật liệu composite. Và gia công vật liệu composite thì nếu mà bằng phương pháp khoan chẳng hạn thì người ta sẽ sử dụng cái four flute dagger hoặc là two flute dagger này chúng ta cắt. Và trong quá trình cắt thì có hai yếu tố mà chúng ta cần phải để ý. Thứ nhất là lực cắt, và cái thứ hai là tốc độ mà chúng ta đưa cái mũi cắt vào. Đúng không? Nếu chúng ta dùng lực cắt lớn quá thì nó sẽ có cái phá hủy liên quan đến cái việc là hạ cái mũi cắt xuống, đúng không ạ? Thì như vậy nó sẽ làm tách, sẽ làm xuất hiện những cái vết nứt do cái việc tách các cái lớp vật liệu, sinh ra do cái việc ấn cái mũi cắt này xuống sâu quá, đúng không ạ? Xuống sâu quá với cái lực cắt nó để cố tình tạo lực cắt lớn, đúng không ạ? Và cái thứ hai là cái tốc độ đưa vào nó cũng lớn quá, đúng không ạ? Thì nó sẽ sinh ra cái nhiệt do ma sát, và cái nhiệt do ma sát này thì nó sẽ làm quá nhiệt cái vật liệu nền là polymer, và như vậy ảnh hưởng tiêu cực đến cái cơ tính của vật liệu sau cái quá trình mà chúng ta gia công chế tạo vật liệu composite. Và cái khó thì liên quan tới gia công cái vật liệu composite gia cường bởi cái sợi Kevlar này, bởi vì trong cái quá trình mà chúng ta khoan ấy, thì nó dễ sinh ra cái hiện tượng xơ, nó làm ảnh hưởng đến cái độ chính xác của quá trình gia công và đến cái chất lượng của cái lỗ sau khi chúng ta tiến hành khoan chẳng hạn. And here we have the opportunity to discuss with others the content regarding fiber polymer composite for aerospace structures. So now we can talk about different kinds of polymer, and we focus on the differences in terms of the matrix materials. So for example, here we can discuss the polymer-based composite, and afterward we can discuss the metal-based composite and the ceramic-based composite. In an aircraft, people use mainly polymeric-based materials to fabricate different parts of an airplane, and the use of polymer matrix materials is account for approximately 50% in modern aircraft. And the matrix is polymer, and it is often the thermosetting resin like epoxy resin or the bismuth imine. Sometimes high-performance thermoplastic like polyether ketone can be used instead of thermosetting polymer, because we know that the strength of the thermosetting material is larger than thermoplastic. However, thermosetting cannot be recycled comparing to the case of thermoplastic, because thermosetting had a higher degree of cross-linking, and when you heat at high enough temperatures, instead of low separation between chains, carbon chains, and it tend to be burned instead of melt, and therefore thermoplastic can be recycled, whereas the thermosetting resin cannot be recycled. Function of matrix phase, and we have already discussed more or less at the beginning of this chapter, where we introduce that the matrix phase can be used to bind the discrete reinforcement into solid materials, and practically the reinforcement is used to withstand the external load, while the matrix phase is used in order to transfer the load and to bind the reinforcement together and to form the solid materials. Matrix, yes, can also be used to transmit the force to stiff and strong fiber, or to transmit the force to the reinforcement, because the reinforcement is the factor that withstand mainly the external load, not the matrix, because it's weak. It's made of polymeric material and is weak. And also the matrix can protect the fibers from the influence of moisture and the abrasion, like in the case of friction abrasion, dạng ma sát hoặc là mài mòn. Còn moisture thì is like humidity, yes, with their water gas, concerning water gas. Hybrid composite can also be used for aerospace applications. So, for example, we use two different kinds of fiber reinforcement in order to reinforce a composite. So let's say we use the aramid fiber and carbon fiber to fabricate a composite, aimed at increasing the ballistic resistance of materials. À, để mà nói cái từ ballistic này thì tôi vẫn hiểu nó một cách nôm na là nó liên quan đến vấn đề về mặt súng đạn. Nhưng mà cái khả năng chống chịu về mặt súng đạn thì tôi cũng không không tìm được ra cái từ để mà dịch thoát nghĩa cho các em về cái từ này. Nhưng mà về cơ bản thì những cái vật liệu composite ấy, mà dùng có cái sự kết hợp về sợi Kevlar này và sợi carbon để gia cường cho cái polymer matrix ấy, thì nó sẽ góp phần nó tăng cái độ bền và tăng sức chịu đựng, đặc biệt cho những cái vật thể projectile, là vật thể mà bắn đi. Đó, tăng sức chịu đựng cho những cái vật thể như thế. Nó dùng chủ yếu cho lĩnh vực quân sự. Glass and carbon fiber hybrid composite. So we use a mixture of glass fiber and carbon fiber in order to fabricate a composite. And these applications, and this can be used for the helicopter rotor blade applications. Yeah, rotor blade. And composite used in the aircraft structures. Yeah, and we use mainly in the form of laminate or sandwich material. So we have already distinguished two main forms of composite materials, either in the form of laminates or sandwich structures. And for sandwich structure, it can withstand good the bending and the buckling failure. So here it's just to remind you about the laminate composite and sandwich composite. Laminate composite contain continuous fibers in a polymer matrix. We can orientate the fiber in different orientation, or we can arrange. Yes, we can use the word arrange, or align the fiber in different orientation, but is should be in plane. Yeah, should be in plane. And this can be used for the heavy loaded composite structures. And this can withstand quite good the force oriented along the direction of the fiber, but in other directions, yeah, we cannot withstand as well as the direction that we have mentioned. That's an issue of composite materials reinforced with the fibers, because only in the directions that we reinforce with the fiber, and this direction can withstand good load. Otherwise, no. This is the reason that we call composite having anisotropic properties, and we try to orientate the fibers in different directions in order to approach the quasi-isotropic properties for this type of materials. And quasi-isotropic, so approaching the isotropic properties. Sandwich structures we use in lightweight secondary structures. Those need high buckling resistance and flexural rigidity. This means that it can resist the bending and to resist or to prevent the structure from damage by buckling. And on the right side, you could see the micrograph of the an aircraft grade composite materials reinforced with a fiber. And in the adjacent area of the fibers, we have the polymer matrix, and we can see about the scale of 50 micron for this. Yeah. So we have the reinforcement phase, we have the matrix surrounding the fiber reinforcement in order to bind the fiber uh, within composite to make the solid materials, of course. Yeah. And below you have the graph showing the relation between the tensile strength as a function of the fiber length. So basically, increasing the length of the fiber, we can increase the tensile strength of the composite materials, yeah, up to a certain point. So for example, uh, let's say 350 megapascal, if the fiber length reaches 60 millimeter, 60 millimeter. Yeah, carbon reinforced polymer composite. And yeah, fiber polymer composite can be used for the military aircraft, yes, to fabricate the lighter fighter aircraft. In fighter aircraft and helicopter, yeah, we can use the fiber polymer composite to fabricate different parts. For example, the wings, the fuselage, to minimize weight and maximize the structural efficiency, and several military aircrafts using composite uh, materials for fabrication, like the F-14, F-16, F-22, F-35. And you see that F-35 Lightning II can contain 35% of carbon fiber epoxy composites. So quite large amount of materials are carbon fiber epoxy composite materials. Yes, because it's strong, stiff, yeah. At the same time, it's light. Yes, so it can help to minimize weight at the same time maximize the structural efficiency. Yes, of the airplane. So you see that for the mid fuselage, yeah, cái thân ở giữa đúng không ạ? Skin can be made of composite or titanium alloys. The bulkhead and frame can be made of titanium, aluminum, and composite. Fewer floors. So we have already discussed about the floor beam. It's made of composite, and the composite is created based on, for example, uh, punctuation technologies. Yes, the weapon bay door is made of composite, so quite large amount of material in the aircraft, all of the aircraft are composites. Composites. But keep in mind that yes, we are talking about the fiber polymers composite, uh, and we have the matrix material is polymer, and it should not stand close to the area working at high temperatures. The area withstanding high temperatures, like in the case of engine. Yeah. Yes, so yeah, we do not know so much about this fighter. Yeah, just some information to show you that in addition to the titanium alloys, the aluminum alloys, we can also apply composite on fabricating other parts of the fighters. This is the B2 bomber, yes, which can be made of, for example, fiberglass epoxy. This is the hybrid composite. I'm sorry, fiberglass is, yeah, no, this one, the fiberglass and polyimide. Yeah, this is the hybrid composite. Yeah. We can also fabricate composite having the graphite as the component of the composite, which can be used to reinforce the epoxy resin. Yes, but again, it's quite difficult in order to recognize uh, which one is the area which is made of fiberglass epoxy or graphite epoxy or titanium. Yeah, with this figure. Probably they used to describe the situation to a certain extent, but at the same time, they want to keep secret about the material that is designed for making uh, B2 bomber. Yeah, it's transparent for the radar, and therefore the polymeric material should be radar absorption to avoid the reflection of the radar wave. Or you can use different kinds of coating like pen in order to, how can I say, absorb the wave and release in the form of heat instead of uh, reflecting the signal, of course. It's just for showing you, yeah, the application of fiber polymer composite. Yes, and apart from the application on the passenger aircraft, and it can also be used for making military application like a military aircraft. And for the commercial passenger aircraft like Airbus, the biggest ones, 380, yes, 280-ton airliner, which is built from 25% of composite materials and mainly the carbon fiber, reinforced epoxy composite. And this material is used to make the major structural components. For example, the vertical and horizontal tail plane, tail cone, wing box, wing ribs. Yeah. And in the case of Boeing 787 Dreamliner, and the, how can I say, Boeing used around 50% of composite for fabricating structural components, and the composite material, which is mainly used for fabricating the structural component, is carbon fiber epoxy composite. And below, yeah, of course, you see the figure showing you different parts inside of the Airbus 380, which are made of composites. So CFRP stands for the carbon fiber reinforced polymer. Yeah. So the main application. So the carbon fiber reinforced polymer composite is mainly used for fabricating different, yeah, uh, component inside the Airbus 380. And on the right side, you have a table summarize some information concerning the composite component on the Airbus or Boeing airlines. For example, yeah, fuselage, yeah, fairing. Yeah, I know fairing is something which are not important. Pressure, bulkhead, yeah, floor beam, yeah, wing box, wing scale, vertical tail plane, and so on. Yeah, I do not familiar with actually the structures of an entire plane. This is not my major for sure. Fiber polymer composite for aerospace structures. Composite can also be used in helicopters or gas turbine engines. Surprisingly, because for the engines we need the materials having the ability of withstand high temperatures. Yes, and actually this can be used to make plate, for example, but not for making, for example, the high pressure stage plate or the combustion chamber and so on. Yeah, of course, it's possible for uh, composite. Helicopter. So we can use carbon or glass or aramid fiber composite in order to fabricate the main body or tail boom of the helicopter in order to reduce weight, reduce the vibration or corrosion. Yeah. Or we can replace the aluminum structures uh, by using the composite for making, for example, main rotor plates. And by replacing the aluminum materials and use composite instead. So, for example, the carbon fiber reinforced epoxy composite, we can prolong the life, and at the same time we can increase the fatigue resistance up to 20,000 hours. Yeah, surprisingly. For the gas turbine engines, we can use composite for making fan blades, front fan case, yeah, and so on. And with this, I mean using the composite for making fan plate or others, we can save from 20 up to 30% of the total engine lifetime operational cost. And since we use the polymer-based composite to fabricate these parts, and therefore, yeah, polymer cannot withstand high temperatures, and this limit the maximum operating temperatures to down to just 150 degrees C. Because above these temperatures, we soften the material and distort the structures. What is it? Someone has raised their hand, or someone asked me for permission to exit the room. We can also use the carbon fiber bis to reinforce the bismuth imine, and this is the choice for jet engines. And we can use the composite for the gas turbine engines in order to lower the weight and to increase the structural performance and to reduce the maintenance costs. And if we use the composite to make fan blades, we can save the weight of other components, since the weight of the blades are reduced, and therefore this reduce the centrifugal force, and therefore the structures which hold the blades will be smaller or just need to withstand the lower force, and therefore you can save the weight of other components. So the stronger the component, the heavier the structure are. And if you need to carry out the fan blades having lower weight, and therefore the carrying structures will be smaller or lighter, and in this way we can help to improve the fatigue life. Did you get the point? Lấy một cái ví dụ như thế này, chúng ta có các cái cánh quạt, đúng không ạ? Các cái cánh quạt này nếu mà sử dụng vật liệu composite để chế tạo thì nếu mà đem so sánh với vật liệu kim loại nó sẽ rất là nhẹ. Bởi vì cái density hôm trước chúng ta có nói là cái density của vật liệu composite nó chỉ rơi vào khoảng cỡ 1.6 đến 1.7 gram trên 1 cm khối, trong khi ở vật liệu titanium nó rơi vào khoảng 4.6, vật liệu thép thì nó rơi vào khoảng 8 chấm gì đó gram trên 1 cm khối. Aluminum thì cũng phải là 2.7 gram trên 1 cm khối mất rồi. Thế thì các cái cánh quạt này nó phải được giữ ở trên một cái ổ trục, đúng không ạ? Tất nhiên là nó phải giữ trên một cái thiết bị này nó sẽ xoay quanh một cái ổ, chúng ta phải có cái trục nào để đỡ, đúng không ạ? Thế thì khi mà cái khối lượng của cái cánh quạt này, tất nhiên là ngoài cái lực tác dụng vào, đúng không ạ, thì tự trọng của nó cũng sẽ được giảm đi nếu như chúng ta chế tạo bằng cái vật liệu composite, dẫn tới là những cái thiết bị dùng để đỡ nó cũng chỉ cần chịu cái lực nhỏ thôi, nhỏ hơn thôi. Thì khi mà người ta chế tạo những cái thiết bị đỡ đó thì người ta chỉ cần chế tạo bằng cái vật liệu có thể là rẻ tiền hơn, hoặc là kết cấu nó sẽ nhẹ hơn, bởi vì kết cấu nhẹ thì nó sẽ chịu được lực nhẹ thôi. Thì thông qua đó thì chúng ta sẽ giảm được cái khối lượng hoặc cái trọng lượng của các cái thành phần khác đi kèm với cả những cái cánh quạt này, nhờ cái việc giảm đi được cái lực hướng tâm, đúng không ạ? Đó, centrifugal lực ly tâm, lực này lực ly tâm, và do đó là nó làm tăng cái fatigue life của chúng ta lên. Thì tất nhiên là cái fatigue life thì nó phụ thuộc vào nhiều yếu tố. Thứ nhất là nó phụ thuộc vào cái số chu kỳ mà chúng ta tác dụng vào một cái chi tiết. Cái thứ hai là nó phụ thuộc vào cái tần số làm việc. Cái tần số làm việc. Cái thứ ba là cái độ lớn của tải trọng. Và thứ tư là môi trường làm việc nữa. Thì tất nhiên là khi mà nói là khi mà giảm cái trọng lượng của cái fan blade và tăng được fatigue life thì nó chỉ là một cái khía cạnh thôi, chứ không phải là nó là tất cả các yếu tố để mà tăng fatigue life cho cái kết cấu của cái plate hoặc là kết cấu của cái động cơ này. Nhưng mà cái nhận định chung là khi mà chúng ta giảm được cái trọng lượng của cái fan plate thì những cái kết cấu đi kèm thì nó sẽ cũng được giảm cái trọng lượng, nhờ đó mà chúng ta tăng được cái tuổi bền của cái chi tiết đó lên. And now we can discuss the disadvantages and advantages of using fiber polymer composite for aerospace structures. So we have several advantages. So for example, the width. We have low width when fabricating the part by using composite. Yes, because density of composite material is lower comparing to the case of metallic materials like aluminum, titanium alloys, or steel alloys, or nickel-based superalloys. At the same time, fiber polymer composite uh, have superior mechanical properties if we compare with the aluminum alloys. And if we substitute the aluminum alloys by using carbon fiber composite, we can save 10 to 20% in terms of weight, while the performance are similar to a certain extent. And because it depends on the specific type of composite and the specific type of aluminum alloys. 2000 series alloy for aluminum, 6000 series alloys for aluminum, and others. Which type of composite? Carbon fiber reinforced epoxy, or glass fiber reinforced epoxy resin, or the Kevlar fiber, and so on. So, in general, if we use, uh, let's say, carbon fiber composite to substitute the aluminum alloys for fabricating the structural component inside an aerospace, how can I say, inside an airplane, for example, and we can have somehow similar performance, but we can save 10 to 20% of weight. We can integrate it manufacturers. This means that we can reduce the number of the parts when they are fabricated by composite. And this helps to reduce the example cost and part count. Yes. So let's think, for example, if we have two different small plates which are made of composite, and we have several options in order to join them together using adhesive as an example. But for metallic materials, it's not always possible to using adhesive to attack them together, and therefore you need to wet, or you need to drill the hole in order to assemble with fastener. In other words, with using composite, in many cases we do not need to create the holes for example by using fastener, and therefore we can help to reduce the example cost and the number of parts. Structure efficiency, uh, whether it's really behave efficiently or not. These are questions. Because in general we can align, or theoretically we can align the reinforcement in the lot of directions. But in fact, it's quite difficult or impossible to predict the load, uh, because it's applied to the structure randomly. And certainly, for example, there is a bird collide with your structures, like the cover an airplane. So yeah, whether the part will be damaged or it can survive. Of course, we have to predict, we have to design, but basically it's almost impossible in order to calculate or to consider all situations. But generally speaking, we can align the carbon fibers, for example, in the load direction to support these directions, because the reinforcement is the phase that are designed to withstand the external load, and the matrix will be responsible to transfer the load to the reinforcement. But if the load is applied to the direction which is different from the orientation of the reinforcement, so this is the question for you. Yeah. Fatigue resistant, high fatigue resistant, or you prolong the fatigue life of the part when they are made of polymer fiber polymer composite. And if the fatigue life of the part increase, you can reduce the maintenance cost. Yeah, you can reduce the maintenance cost. It's easy to understand. Several polymer-based composites are immune to corrosion, immune, miễn dịch, immunization system, uh, immune to corrosion, and and these materials help to reduce the cost of inspecting and repairing. And generally speaking, metal like steel are susceptible to corrosion, and for this type of metallic material, we have to inspect and to be ready for repairing uh, more frequently. Yes, and for this account for a certain amount of cost. Radar absorption properties. Yes, for several polymeric materials, they are transparent uh, to the wave, radar wave, and this helps to how can I say, to avoid the detection by using radar. In the case of military aircraft, or you can use the bone paint, so that when when the radar reach the surface of the object, and the pen containing the bones inside will receive the energies and vibrates around positions, let's say, for example. And during the vibrations, it will release the energies in the form of heat, and therefore minimize the signal of the reflected wave to the radar, and therefore this can help to hide the object. And the radar absorption properties of the several polymer or fiber polymer composite uh, have, how can I say, certain advantages for military applications, especially military aircraft. Uh, Heat insulation, yeah, it's quite difficult to talk to discuss with the polymer can act like a heat insulation, cách nhiệt, đúng không? But to a certain extent, several kinds of fiber polymer composite can help to reduce the heat conduction from the engine through the fuselage. So it's help to be harder to detect by using infrared device. Cái thiết bị mà dùng để phát hiện ra các cái vật thể nhờ nhiệt, đúng không ạ? Bởi vì nó cách nhiệt rồi thì nó giúp đỡ được cái điều đó. Tuy nhiên là chúng ta không đưa ra cái ví dụ cụ thể ở đây, thì nói những cái ưu điểm chung chung của cái việc sử dụng fiber polymer composite cho cái kết cấu ở trong hàng không thôi. Low coefficient of thermal expansion mean that we can guarantee the high dimensional stabilities with the change in temperatures. So everything has two side effects. So we also have some disadvantages associated with using fiber polymer composite for aerospace structures. For example, high cost. Yeah. So, for example, regarding the carbon fiber fabrication, do you still remember about the process? First, we have to sketch the polyacrylon nitride fibers or filament. And during the sketch, we pass the polyacrylon nitride fiber to the oven, where we maintain the temperatures of around 200 degrees C in the environment having the oxygen to promote the oxidations. And during the oxidation process inside the oven at around 200 degrees C, we have the formation of the cross link to link different chains together. And at that time, we still sketch keo căng polyacrylon nitride fibers or filaments. And after this stage, the polyacrylon nitride are passed through a furnace where we maintain can be the vacuum or the argon inside to prevent further oxidation. And we maintain relatively high temperatures of around more than around 1,500, let's say, degrees C. And during this stage, we eliminate the substituent group, nhóm thế, and eliminate the atoms of oxygen, nitrogen, hydrogen, and other, and left the carbon fiber, the carbon backbone chain. And if we leave the material there, and we have high strength carbon fiber. But if we need the high elastic modulus carbon fiber, and we need to pass the carbon fiber through the next stage to treat the carbon fiber at higher temperatures, At lower temperatures, we call the carbonizations. At higher temperatures, we call the graphitizations. And these can be treated at around 2500 up to 3000 degrees C. And we have the high elastic modulus carbon fibers. And during uh, this process, yeah, you can change the properties, but you apply, yeah, heat. The process is complex and therefore is add up the cost. It add up to the it add up to the cost of the final products of the carbon fibers, and therefore is generally expensive. Also, we how can I say, the fabrication of the fiber polymer composite is labor intensive natures, is costly because we require the use of how can I say, high skin labor in order to fabricate the composite. At the same time, this is the low productions, or we fabricate the part individually, uh, part by part. So the productivity is low, and therefore is increased the cost of the composite. Needless to say, if you need to create a hole, so for example, machining composite for certain purpose, and machining composite is not so easy, and the tooling cost can also add to the final cost of the materials. So in general, composite uh, is buying composite is expensive. Slow manufacture, yeah, I have already discussed low manufacture and therefore low productivity and therefore high cost. And the reason for slow manufacturing process is you have to lay up the fabric. You need to consider the time for curing process in an autoclave, for example. And yes, this prolong the process, and that's why we uh, can say that fabricating composite is slow. Despite of this, yeah, uh, composite behave uh, anisotropically, because we add, for example, a layer of the resin, and next is the layer of the fiber reinforcement and another layers. So the layer based approach, and therefore the properties of the material is anisotropic, somehow similar to the case of additive manufacturing, where we fabricate the part additively, and therefore the final material behave anisotropically. And low through thickness mechanical properties. So it means that the property in the direction uh, perpendicular, being perpendicular to the plane of the composite is weak. It's weak. Yeah. Or, or we can say low through thickness mechanical properties. So the in plane properties is good because we have the reinforcement uh, in the plane oriented along the plane, along different direction on the plane, but in the direction which is in perpendicular to the plane that we have mentioned, the material is weak. Okay. Material has, to a certain extent, low impact resistance, and can form delamination cracking at low energies, which reduce the compressive strength and reduce other properties. For metallic materials, especially the ductile material, it has high damage tolerance. So it means that even it can be deformed, but the functionality of the material or the part is still warranty. And afterward, we can replace by the new one. But if the part does not have damage tolerance, so it can uh, suddenly broken down, can be suddenly broken down, and therefore, yeah, a serious issue may happen. And for the composite material, we need over design to ensure the damage tolerance. So over design means that we increase the weight of the materials and the cost of the part, of the final parts. So for example, if thickness is just need 5 millimeters, but now we need to add additional 3 millimeters, so in total 8 millimeters to guarantee the damage tolerance, for example, and therefore it increase the weight and the cost of the material as well. Not sensitivity. Yeah. And so for example, we if we have uh, uh, the notch, the shape, the V-shaped notch, for example, or the area of high stress concentrations, is very sensitive. Is very sensitive to the notch or to the area with high stress concentration, because we easily to have and the material easily have the crack delaminations damage, for example, and the material has relatively low operating temperatures, typically in the range of 100 and 150, because the matrix material is made of polymer, and polymer, uh, the operating temperature cannot be so high. So just below 150 degrees C, as we have already discussed. Flammability, khả năng cháy, đúng không ạ? So fiber polymer composite can be burned, and during the burning process, it creates smoke together with heat. So it's quite dangerous. So in the, for example, if there is a burning accident, uh, human can die because of smoke before they are die because of heat, because of high temperatures. Low electrical conductivity, yes, which means that it's hard to dissipate electricity in the event of lightning strike. Yeah, yeah. So, so an airplane is in the air, and there is a light strike the airplane. So, yes, for the fiber polymer composite, we have difficulty in terms of the dissipation of the electricity. Yeah. Vâng ạ, máy bay đang bay trên trời tìm đâu ra nối đất để mà dẫn được cái điện từ tia sét ạ. Và tất nhiên là vật liệu composite thì rất là khó tản cái lượng điện đi ạ. Và okay, so now we have let's say around 10 minutes break, and then we can resume the lectures and continue slide 31. So let's have more or less 10 minutes break.